All right, here we are, right? Mr. G Math prepping for your Unit 8 test. Yippee. Unit 8 had to do with differential equations, slope fields, growth and decay, L'Hopital's rule with some trigonometry. So let's see how we do. Number 1. We've agreed that we're going to go slow enough, right? And when the bell rings, it rings. So number 1, find, and there's obviously no room on this sheet to do work, so don't even pretend to try to do it. Find an equation in this form of this differential equation containing the point 0, negative 2, where k is a constant. Let's write it down. Y prime equals k, y minus 2, and it goes through the point 0 and negative 2. All right, that's a Diffie Q. You're asked to solve and tell me what y equals. Step 1. Y prime is dy by dx. Step 2. Yeah, we call separate the variables. And usually the first easiest step is to multiply both sides by dx. I know you're going to be a little confused, but you're smart enough not to be. K is a constant. It doesn't go with x or y in terms of that, right? You could technically go with either one, but it'd be easier to just keep it with x rather than the fraction that will be on the left side. So how do I separate the variables? What am I going to divide by? So divide by y minus 2. I'm leaving k on the right side. If you can do that, you get a point. Now, the calculus part. What's the calculus part? Go ahead. What's the integration of dy over y minus 2? And what's the integration of k? Kx plus c. All right. How do I solve this for y? How do I undo a logarithm? I write it as an exponential. How do I do that? So what's inside the logarithm I write down. What exponential, what logarithm has that base? What base do we need for the exponential? And then what goes in the exponent? On the right side, I'm going to separate it into two e's. One e goes with c, and one e goes with kx. That's an exponent law. How do I remove the bars?
You do the plus or minus of e to the c.
At this point, and you have to write down, you're doing a test, not just in your notes practicing, like on a test, right? What are we going to do? On the AP exam, what are you going to do? You're going to, on the side, tell me that you're going to replace that constant with that one. They are different constants. We're doing it to make it simpler. So take out the plus or minus e to the c and replace it with a different constant variable. Now, at this point, it's just as easy to plug in to see what C1 would equal. Remember what the point was again? 0 and negative 2. Is it wrong to add 2? No. It's probably just as easy. But I'm going to do it this way. So y is negative 2. K is 0. And the challenge is, if you add 2, guess what you're going to have to do anyways? Subtract 2, right, to get it by itself. I know, right? Silliness. Silly Mr. Gertson. You're right. I flip-flopped it. So 0 is x. K is there. What's 0 times k? And e to the 0. And 1 times c1. So c1 obviously is equal to. Some of you are still in this bad habit. Here's the bad habit. That you think that's the end. That you stop there. And it's only a bad habit because you did all the great work. Why not get full credit by telling me what y equals? So what's C1 again? And it's e to the kx, we don't know what k is, it's just kx, where k is a constant. Do you remember we had y subtract 2? So how do you get y by itself? Done. Full credit. What a good student would do after this is to go over the prep sheet again and not just say I did it in class and look at your notes and just pretend by looking over the problem again, it means the same as doing the problem over again. You know what I mean? Good students don't just think I did the problem in class, so if I just look it over again in my math notebook, that's good enough. I'll just look it over. If you do the problem again, that's much better. Number 2. Was that a good pace? Thank you. Number 2 says, and I'll just use the sheet itself. I'm going to annotate on here, but then I'm going to go over to the answer sheet. $1,200 is invested in an account compounded continuously. Remember that? Is that in your memory bank from a year ago? PERT. What is the interest rate? That's what I'm looking for. If the amount triples in 20 years. Okay, let's go over. Now, we don't use PERT. You can, by the way, and get the same answer. But we didn't use PERT when we did our unit, did we? You know what we used over and over again? It was y equals CE to the... Okay, it's fine. We can do that. Now, what information can I plug in? What do I know? What numbers do I know? First of all, how much are we starting with? That's what C is. That's always going to be your initial amount. If you triple it, can you triple?
Yep.
What would it be?
3,600.
E is in your calculator. K is the growth rate. That's what I'm looking for, right? The interest rate is really what K equals. T, how many years does it take to triple?
20.
All right. I need you to solve for K. And then use your calculator. Does that make sense that that simplifies to 3?
Yes.
Why? Triple. So technically, did I even need to care how much money you started with? Didn't matter how much. The K would be the same answer. It matters when you triple it, you're going to have 3. How do I solve an exponential equation? Is I write it as a logarithm. How do I do that? What's in the exponent?
20K.
What logarithm has a base of e? And then what goes inside it? And then the last step is to divide both sides by 20. Now, we don't need to store this in because this is the end of the question. If it asked you something else, how much money will be in there in 30 years or whatever, then you need to store it and use it for the next part of the question. But we don't have the next part. We just have this. So we just got to make sure that we write it properly. Now, in the question, it doesn't say to write it as a percent, but I'll write it both ways in case you see it both ways. So, ln 3 divided by 20. I get 0.054. Don't try to be tricky. And don't tell me I'm wrong. We're going to truncate. All you're going to do is make mistakes. Now, if this was a percent, you would need more numbers. That's because you need to move the decimal 2 to the right, but now I need more numbers to fill out the percent. So what is the number after 4? 9, and then... If they don't ask for it as a percent, they just said the rate, right? If they said the interest percent as a percent or a rate, both would be correct. All right, number 3. It says solve the differential equation. Solve this stiffy q. dy by dx equals negative 4xy. There is no condition. So there's no particular solution. This is going to have a general solution because there's no point to plug in. Step 1, it's already written as dy by dx. Step 2, we need to separate the variables. The y's on one side, the x's on the other side. So to put the y's together, I'm going to divide by y. I'm just going to leave negative 4 on the right side. And then I'm going to multiply both sides by dx. If you choose to practice, like with your assignments, this should get easier and easier, right? The algebra. So you did step 1 right. Separate the variables. Step 2, what do we do? Integrate. What's dy over y? That would be ln y. What's negative 4x? Anti-power rule. That would be x squared, right? When you divide by 2, I'm going to simplify it as negative 2x squared. How can you quickly know if you integrate it correctly? You could take the derivative and make sure, right, that they match. All right, all I need to do is get y by itself. And c will be in the answer. So how would I get y by itself? And what's on the other side? Now, we can do this, because I think it's good practice anyways. And we can replace that constant. But it's over. This would be a good multiple choice question to see which one is the correct one, right, in terms of solving the diffie-q. Number 4. This is one where you're going to have to store it in your calculator. Number 4. A radioactive element has a half-life of 200 years. How much of 30 grams would remain after 60 years? Half-life already gives me this model. Y equals CE to the KT. You guys are smart enough now to do this. I don't need to know the initial weight. I don't need that at all for half-life. I know that whatever number I put in for C, when I divide it, the answer is going to be 1/2. You are calculus. You can do that step. And then K is what I'm looking for, right? The decay rate. And T, how many years does it take to become half the size? I'm reading number 4. When I read number 4, the half-life is 200. So first I need to know the decay rate, store it in my calculator. So how do I solve for K? I write it as a logarithm and then divide. So in my calculator, I'm going ln 1/2 divided by 200. It's okay to write down the number with 3 decimal places, but you're not going to use it for the next step. So when I do this, I have ln 1/2 divided by, would you expect the answer to be negative?
Yes.
Because it's decaying. Good. So it's negative 0.003. That's fine, but we're not going to use that. We're going to store it now. So highlight over it. Remember the quick way to copy? Control and C. So now it's in my calculator. Okay? Now let's go back. So you highlight over it, Control C. Let's go back. What do I write down again? Y equals CE to the KT. Now, what's the second part? How much of 30 grams? So what does C become?
30.
I know what K is. It's okay to put negative 0.003, but we know we're going to paste. And T. And there you go. Use your calculator. Show that you know how to paste it in there. So what's a quick way to paste? Control and V times 60. Again, round to 3 decimal places, 24.367, and the unit is in grams. All right, number 5. How are we doing? We've worked hard in the unit so that the prep isn't brand new, right? We're reviewing something we actually should know. Awesome. Number 5. Find the particular solution. Again, a Diffie-Q. And this one is a particular solution because they give you a point and they say the end answer should be in the form y equals. So make sure that you have y by itself at the very end. Here we go. Step number 1. Write y prime as? Do it. Step 2. No.
Well, no, sorry.
Step 2.
Separate the variables?
Yes. So how are we going to get the y's together? How are we going to get the x's together? So I'm going to multiply both sides by 4y and multiply both sides by dx. Do not assume that the left side will always be a fraction with a y on the bottom, right? Do good algebra. Don't just assume that this is going to integrate the ln, even though a lot of times it does, right? Yay? Okay. Now what do we do? Good. Both are easy integration formulas, right? On the left, the anti-power rule. What's we do? Instead of y, it becomes y squared divided by 2. And how can you double check you did it right? Take the derivative and it should match. On the other side, Lord help us, right? Integrate e to the x. That's it, right? That's the best of the best right there, ain't it? And then the candy. Now, what can I do? You can plug in now. Do you want to plug in now? Let's do it. So, let's plug in -4 for... We have to be careful when we do it this way, and you're going to find out in a second. But we can do it this way. And then e to the...
0.
All right, can you simplify this? I'm pretty sure this is 32. And then e to the 0 is 1. Don't forget that. So you're going to have to subtract. So what does c equal? All right, let's come back here, but you're going to see what I mean in a moment. So we found c is 31. If I want y by itself, what do I have to do next? So we're going to divide everything by 2, which is fine. I'm not going to be complicated about it. This is where you're going to make your mistake. What do you do next? Now, when you solve a quadratic, the answer can be positive or... Yay. So what is it? Perfect. Okay? If you chose to divide by 2 and get y by itself and so on, you'd still get the same answer in terms of doing it. We good? But this is where you could make the mistake, right? Understanding when that should be positive or negative. All right, number 6. Number 6 says f at 3 equals 10, f prime at x equals ln x, and then it says what? Okay, so this is not from Unit 8, but it will be on your test. But this kind of question, in one form or another, has been on pretty well every single test. It's called a starting value problem. Where does the value start at? What number? Can you write that down, please? This is my goal, right? To find f at 6?
Yep.
So how do I find it? What number? Where do we start at? Starting value. Start at 10. And what else do I know? Well, I'm going to add, even though this next answer could be positive or negative, what are you given? So you're given the derivative. And the derivative is ln x. So, in order to understand what f at 6 is, we need to understand that that derivative is a rate that tells me whether it increased or it decreased. So it increases or decreases at that rate. But if I want to find the exact number of what it is, I integrate that derivative. So I'm integrating, right? And what am I integrating? Ln x. Now think it through. What x value was it at 10? So we're going to start at what number? 3. And what am I looking for? So we're going to integrate from 3 to 6 ln x. And that will tell me whether it increased or decreased. Do you know how to integrate ln x? What's the integration of ln x?
1 over x.
If you had your calculator, do you know for sure? If you have your calculator, right? You can check, right, with your calculator? What does it say?
X times
How about this? What's the integration of 1 over x? That's ln x. So, just as a recap, the integration of 1 over x dx is that we know. This? I don't know. It's its own rule. Now, if you look at your calculator, what is it? X times ln x subtract x. I didn't teach you that, right? We're not there. This is a calculator question right now. So, what am I going to put in my calculator and round to 3 decimal places? Please do that. But do you see if you have a calculator, you don't have to assume. Right? You can type it in and make sure. Make sure you go to the integration that has bounds, right? So it's 3 to 6, and then what do we put in here is ln x, and then dx. And then what did you get the answer for f at 6? So 14.454. There's always a question like that on the test, right? Where you just needed to put in your calculator, you get it wrong, and you feel dumb later. Remember those kind of questions? And then you try so hard to do something tricky with it, and you think you're all that, and you got all this stuff, and all what? I just type it in my calculator question. Is there another one on this page? Probably not. I don't know. All right, limit questions. What do you think this might deal with? Limit questions. So, L'Hopital, right? Our favorite French calculus guy. Now, any limit problem, listen, any limit problem you always start with is a substitution. That's all it is. It's a plug-in problem. So can you plug in 3? And we know it's L'Hopital's rule if it's indeterminate after you plug in 3. 3 squared times 2, take away 18, that's 0. 3 times 3, take away 9, that's...
0.
Is it indeterminate?
Yes.
Good. Now, we're not going to do, the top is increasing faster than the bottom. Why not? It's not going to infinity. Thank you. So, it's going to a constant 3. So, I am going to apply L'Hopital's rule. So, I recognize it's indeterminate, right? So, what is L'Hopital's rule? Now, notice I didn't leave the limit notation, right? I still wrote it down. The derivative is 4x, and on the bottom is 3. Now, what do we do? And that, I don't need the limit notation once it's over. Okay? All right, let's try the next limit question. Oh, can I show you something real quick? Do you know that question, if you had your calculator, you could press, do you know what button to press? Oops. Do you see something that says limit?
Yeah.
I see it. Do you see it?
Yeah.
Okay, press enter. And what would you type in?
X
as x approaches what?
3.
And then don't worry about that cute little exponent. It can be left blank if there's no exponent. Then go inside the parentheses. And what would you do? Do you know how to do a fraction? You go control divide. How did I do a fraction again? Control divide. How did I do it again? Stop it. Omi. Control divide. And then what goes on top? 2x squared. Oops. Oops. Subtract 18 on the bottom was x subtract, or 3x subtract 9. And what's the answer?
4.
So if you have a calculator, and it's the calculator part of the test, it's not cheating, to know how to find a limit with your calculator. I bet for some of you that was brand new. You knew it? Next one. These would likely be non-calculator questions because of that, but you never know. So the next one, the limit as x approaches infinity, and it's 2x squared subtract 18 over ln x. Now, could this actually fall into that category about which one is increasing faster? First of all, it's indeterminate because both the top and bottom are going to infinity. Second, the top is increasing faster, so the answer is infinity or
DNA.
does not exist. Do you know how to type that in your calculator if you wanted to? Do you know where the infinity button is? So, if you went to limit again, you went as x approaches infinity. Do you remember what button we pressed for infinity?
I don't know. Oh yeah, pi has it too. Pi has it too.
Oh, does pi have it too?
Pi has it too.
Yay! So if I just press the pi at the bottom, I can also get to infinity. And then don't worry about the first box. That's if there's an exponent. And then you would type in the fraction 2x squared subtract 18 over ln x. Isn't that cute? And then what answer do you get? So it's just a skill, right? If you get to use your calculator and you're asked to do a limit, easy peasy. Next one. The limit as x approaches pi of sine x over 2 over 3 cosine x. All right, this will worry me. This is a substitution problem. So we're going to, on the side, we're going to plug in sine pi over 2 over 3 cosine pi. Do you know what the value of sine is at pi over 2?
I don't remember the unit circle. It's been a long.
So, you need to do that lesson you haven't done. There is trigonometry on this test. Just the real basic stuff from Math 3. So, sine, on the unit circle, by the way, is the y-coordinate. And pi over 2 is at the very top of your unit circle. What's the y-coordinate at the very top? What's the y-coordinate at the very top? So, the top is 1. Pi is on the direct left. It's 180, right? And the point there is -1 and 0. And so what's the value of cosine at pi? What's the x-coordinate there?
It's -1.
So it's 3 times -1. So this answer is, up here, -1/3. Now, by the way, if you put this in your calculator, it would give you the answer. The problem is, or the challenge is, to make sure your calculator is in radians so you can calculate it. So you have to see RAD or else change the settings, okay? Is there one more in here? One more. Number 8, same one, 7. Another limit question. The limit as x approaches -3. It's a fun looking one, isn't it? When it's fun looking, do you quit? Or do you think, man, that's kind of fun. Let's see how I can figure it out. All right, I'm going to help you. You ready? Step 1 for any limit problem is to plug it in. So where there's an x, what am I going to plug in? So not the t, just the x. So the bottom is easy. We know the bottom is what? How about the top? If you integrate from -3 to 3 of this, do you understand what that answer is, either graphically or by doing the algebra? If I understand the graph, t cubed is just a cube function, right? And when I go from -3 to +3, the area above will match the area below, which means the answer is 0. Or you can write t to the 4 over 4, plug in 3, plug in -3, subtract the two numbers, and they'll be exactly the same, and we'll give you the answer 0. This is indeterminate. Either with the graph, or you decide, I can integrate that. That's t to the 4 over 4 from -3 to 3. And when I plug in +3 and -3, you don't even need to know the number. Just know the exponent 4 will make that exactly the same. Any two numbers that are exactly the same, when you subtract them, would equal 0. And the big point is it's indeterminate. It's L'Hopital's rule. So what is L'Hopital's rule? This is not as bad as it sounds. What is the derivative of the top? When you take the derivative of an integration, that's the fundamental rule of calculus, that they are inverses of each other, right? And what would you plug in first? The top or the bottom? If you plug in the top, whatever the number is, and take the derivative of it, that answer is going to be 0. Then you would subtract, and you'd plug in the bottom, which means you take out the t and put in x. You've now taken the derivative and the integration. Fundamental rule of calculus. Derivatives and integration undo each other. And we plug in the bounds. And if this bound had a hook, that hook would need to be included. But it doesn't. The derivative of x is 1. All right, the bottom is just 2. Now what would you do? Do you know what that answer is? -27 and a negative makes it done. Okay? There will be a question like that. Like all of it, what I'm giving you. But that would be one, that'd be gravy, right? If you got that one right on a test. 8. You don't like gravy? Strange. I like gravy. Number 8. Do you have turkey when you do the Christmas Thanksgiving thing?
We have turkey and ham for Thanksgiving.
The Canadian thing to do?
And then
Poor Canadian turkeys. Yeah.
And then we just have tamales, for Christmas.
Yes,
Have you ever tried tamales?
I have.
But like good ones.
Probably not like good ones then. But yes, I have tried them. I'm not a fan, so that's on video. I'm sorry. I'm sorry. That's it. I know, it's over. I dropped the mic right there. What does that mean? I don't know what that means. I'm not against tamales, and if someone said you have to eat a tamale, I would eat it. It would be fine. I just said I wasn't a fan. I wouldn't go out of my way to buy and eat them, but I get it. But maybe I haven't eaten the right tamale to love it. All right, let's try number 8. That sounds like something you'll bring in at lunch for me one day. Number 8. So number 8, you're given that f at x equals this. Can you take the derivative and plug in 1? This definitely smells like a non-calculator question that you need to do. So, do you know how to take the derivative of ln? What you see inside the logarithm goes in the denominator. The derivative of what's inside the logarithm goes on the top. Step 1, and then step 2 is to plug in 1, and then it's over. So that's from Unit 7, right? The ability to take the derivative of a logarithm. Number 9. That should be one of the easier questions, right, on the test. And always, if you want to be a good test taker, you have to get the easy ones right. You're not allowed to make a silly mistake on easy questions. You make silly mistakes on tough ones, not easy ones. Number 9. Find the average value. Here's another one that comes up on every test. Maybe this time most of you will do it right. How do you find the average value of a function from 0 to 3? What's the setup? It's a fraction. What goes on top?
What you see right there?
From 0 to
3.
of 2x root x squared plus 6. What goes in the denominator?
3 minus
The difference of the bounds. All right. This will make life easier if you can do this. Understand that when something is over 3, that means the same as 1/3, and put 1/3 in front. That'd be a great first step. Next, I need to know my calculus. I need to know how to integrate this. So to integrate this, I don't like the square root. So what would you write it like?
X squared plus 6 to the 1.
Now, I want you to see the anti-chain rule here. What is the derivative of the base?
2x.
Is the hook already correct? Do I need to change the hook or have a number in front to keep it the same? It's perfect the way it is. So when I integrate, guess what happens to that hook? Right? Like Peter Pan, right? Tick-tock, Captain goes, right? So, I'm going to integrate now. What number is in front? 1/3. Am I going to worry about the 2x? No. Now, how do I integrate this? So what would that be? What is 1/2 plus 1?
3 over 2.
And instead of dividing by 3 over 2, I'm going to multiply by the reciprocal. And we don't have candy. We're integrating from 0 to 3. So what's the last step? And if this was free response, I don't want you to go any further than the next step. So guess what? I can write this as one fraction. That's easy. That's 2 over... Is that 2 over 9? And then what number goes in for x first? And then do you add or subtract? Again? And now what number goes in? And now it's over. That's finding the average value of the function from 0 to 3. All right, 10. Trapezoidal rule. Hooray. What's the trapezoidal rule? What do we use the trapezoidal rule for?
Find that area.
To integrate, right? We're approximating an integration by using what shapes? Trapezoids. All right. So it says, can you integrate from 0 to 8 x squared cosine x? Isn't that nice? Don't simplify. How many trapezoids am I using? 4 trapezoids? And they're all equal size there. So if I'm using those 4 equal size trapezoids, what am I going to start with? So the trapezoid formula starts with 1/2 Each trapezoid is going to be what width?
So
How do you get that?
you subtract. You go 8 minus or upper bound minus.
So you understand that you're going the upper bound minus the lower divided by 4. So each trapezoid is 2. Now what?
And then you get the sides.
We need to know, right? We need the first height, don't we? Do we double the first height?
No, we don't.
No. So what number am I going to plug in for the first height? It says don't simplify, so just plug in 0 for x plus. Do I double the next height?
Yes, you would.
Now, what number do I plug in if the width of each one is 2? What would be the next number I plug in? 2. Do you see how I did that? Don't simplify. Then what number would you use again? We're doubling again, but now we're going to use 4. Don't simplify it. We're doubling again, and we're going to use 6. And then we're going to end this. The last one we do not double. We just plug in 8, and that's it. It's just one parenthesis at the end. I know, the screen's going a little purple. So, the key to the trapezoidal rule is what does it start with? And then the width of each trapezoid, that's the next number, right? Then, the first height, is it doubled? So the first and the last height is what it is. All the middle ones are shared, right? So they have to be doubled. That's the trapezoidal rule, and it's over. Number 11. All right, you ready? So this is not a calculator question. Without a calculator, how would you integrate it? What would be your first step?
To rewrite it.
And how would you rewrite it? So first of all, inside the parentheses obviously would be 16 subtract x. It's in the denominator. That means the exponent is going to be in the fourth root. What is the number fourth? 1/4. So what is this? Now, I need to understand the anti-chain rule. What's the derivative of that base? Was there a -1 there before? So in front, what was it? And what did it become, right? Which is 1 over -1, which ultimately means what sign is in front. Now, this -1, once you have it in place, goes, right? The hook goes. Tick-tock. Then, what do I do to this exponent? What's -1/4 plus 1? It's kind of like you owe a quarter, and then someone gives you $1. How much money do you have now? Right? And then what would I do to 3/4? Divide or the... And then, what do we still have? This, again, unless you're asked to simplify it, right? What would you plug in first? And then would you add or subtract? Realize that we have two negatives here, right? Subtracting and a -4/3. And that -4/3 could have been in front with parentheses too. And then we're plugging in 0. Just because it's fun to do, I'm going to simplify it. I know. Yeah. So, let's look at this. What's 16 take away 15? What's 16 take away 0? All right. Do you know that 1 to any exponent is equal to 1? And 1 times -4/3 is just -4/3. Do you know what the fourth root of 16 is? What number 4 times itself equals 16? And then 2 to the exponent 3 is 8. Then, can you simplify the right side? Notice that the two negatives, now I'm going to get to the point where that's going to be, instead of subtract a negative, I'm just going to make it adding. Do you see how I did that? What's 4 times 8? 4 times 8? That was on video. I won't say your name. It's on video. it'll be our secret, 4 times 8. All right. There you go. And then the numerators, remember the denominator would stay the same. And then the numerators, how about this? Negative 4 plus 32. All right. Beautiful. All right. Wasn't that fun? 12. Am I going too fast? Just perfect, right? All right, here we go. This kind of question you see on every test too. It's testing you whether you're willing to do algebra before calculus. It's testing you. Are you willing to do algebra before calculus? I am. I know that this x belongs to every term above it. What's 4x cubed divided by x?
4x squared.
What's 3x squared divided by x? What's negative x divided by x? And what's 1 over x? We're just going to leave that as 1 over x. All right, integrate each one like it's separate, just each one individually. So the individually, so what's just 4x squared? Integrate that just by itself. That would be 4x cubed divided by 3. How about the next one? 3x. 3x squared divided by 2. How about negative 1? Now we get this. What's the integration of 1 over x? And what aren't you going to forget? The candy bars. Thank you. 13. If you did more, then you're just taking points away. 13. F at x equals 1 over 2x plus 1. It says find the area. Remember how to find area? And what is it bounded by? Y equals 0, x equals 0, and x equals 2. Just for fun, can you tell me and plug in 0 and 2 so you have a sense of what the graph looks like? What would happen if you plugged in 0 for x? What answer would you get? 1. Can you put that on your graph? I think it's nice to see a little graph, knowing the area you're doing. Then, what else are we doing? We plug in 0 and what's the answer? Or plug in 2, what's the answer? Which is somewhere down here, right? And it's a curve. So I just want you to get a sense of the area you're finding. Is that okay? Like that area is what I'm finding. So let's get back to basics of calculus. How do you find the area of something like that? Is that a derivative question or an integration question? And we're integrating from 0 to... What are we integrating? And that's it, right? That's the setup. That's not the answer, but that's the setup. Next step is how do I integrate that? You ready? So, when I recognize it's a fraction, that tells me it could well be a logarithm, right, when you integrate it? Now, what's the derivative of the base? So instead of it, I'm going to write it what it needs to be, which is 2 over 2x plus 1. Now, was the numerator 2 before? What was it before? What did it become? Got it? Now, can you integrate? When you integrate, you don't need to worry about the 2. And I just told you what type of integration is. It is logarithm, right? So the 1/2 in front, and then it's ln of what? And it's integrating from 0 to 2. What's the last thing you need to do? Plug in 2 and then plug in 0. All right, I'll do that over here. So the last step for the answer would be ln 1/2, plug in 2, subtract, plug in 0. That is the area. No need to simplify. And I wouldn't find that fun simplifying. Just the other one would be fun. The other one was fun. This one, just let it go. All right, number 14. Oh, it actually asked more questions for 13, didn't it?
Yes.
So first it said find the area, right? We did that? All right, so now 13 says, what? Set up the integral. Don't do anything more. Just set up the integral of what we had. So if I want to find the volume of a solid revolving around the x-axis, is that a derivative or integration question? What I'm asking myself is that a disk or is that a washer? Is there a hole in it or is it solid all the way around? Good. And a disk is obviously what shape? What area formula? Circle. And a circle is pi r squared, correct? All right, what's going to represent the radius is the function, which is 1 over 2x plus 1, and we're integrating from 0 to 2. That's it. Done. This is the setup. What's the next setup, it says? So this is for revolving around the x-axis. The next one says set up an integral for the volume of a solid, right? With cross-sections of what? A rectangle. So this one, will it have pi in it for a rectangle? Is it still an integration question? So there's no pi. It's not a circle. It's a rectangle. What's the formula for a rectangle? Length times width. You see how I just set it up with parentheses? Length times width. Now, what does it say? Or you can think of it as the base times the height. Now, the base, it says the height is twice the base. So the base is the function, which is 1 over, and the height is twice that. So you can either put a 2 in front or a 2 in the numerator. Same thing. So you can put a 2 in front, or you could have put that 2 in the numerator, and it means the same thing. The base times the height, and the height is twice the base. That's the setup. It's over. All right, now 14. Oh, boy. Just for fun, do you want me to go through these? Even though you haven't prepped yourself with basic trig?
Yes, we have. Let's go through it.
You ready? So, if I want to know what the value of cosine is, my first understanding is it's the x-coordinate, right? So for 7 pi over 2, I need to know what point that is on the unit circle. So, because 2 is in the denominator, that already tells me something important. It tells me it's either going to be at the top of the unit circle or the bottom of the unit circle. Now, at the top would be pi over 2, and at the bottom is 3, and it goes by odd numbers. So 1 pi, 3 pi, 5 pi, 7 pi over 2 will actually end up at the bottom. And at the bottom, it's 0 and, but even more fun, do you notice the x-coordinate is the same at the top or the bottom? So either way, the answer is 0. I didn't even need to know if it was the top or the bottom. The x-coordinate actually was the same on the top or the bottom. Hey, was that fun? Cotangent, 3 pi over 4. What do I need to know is the point and the definition for cotangent. The definition of cotangent is the reciprocal of tangent. Now, tangent is opposite over adjacent, or would be y over x. So cotangent is x over y. So if it's helpful, give yourself a picture. What quadrant is 3 pi over 4 in? And because it's over 4, that gives me the indicator that it's in the middle of the quadrant. And 3 pi over 4, what's in the first quadrant? 1 pi over 4. In the second quadrant, 3 pi over 4, then 5 pi over 4, then 7 pi over 4. So it's in the middle. What are the coordinates when it's in the middle of the quadrant? I heard it. Root 2 over 2 and root 2 over 2. The x-coordinate is negative. Now, if it's x divided by y, first of all, a positive divided by negative, the answer is going to be negative. And I know they're ugly, but when you divide the same number by itself, this answer is negative 1. You know if you need to practice this, right, with the last assignment. The sine of 5 pi over 4. How do I do it? Sine is which? The x or the y coordinate? Now, what is the coordinate? I'll come back to this unit circle above. Remember we were at 3 pi over 4? Where's 5 pi over 4? And it's going to be negative root 2 over 2 and negative root 2 over 2. Both are negative. So even if you forgot which one, you'd still get the right answer. What's the y coordinate here? And the answer is negative root 2 over 2. 17. What's the secant of pi over 2? The value of secant is the reciprocal of cosine. Cosine's x, so the reciprocal is 1 over x. When you think of the unit circle, where's pi over 2? And what is that point? 0 and what's the x coordinate? And 1 over 0 is? That's on video too. I got 4 times 8 and 1 over 0 is 0. Both are on here.
I'll join you.
That's it. You're going to be called out soon. 1 over 0, the answer is undefined. All right, 18. You got too many impact people in here that know how to mess with this stuff. 18, once it's on YouTube.
Hey, Dan, only 3 people yours.
Hey, see, now that was a shot against me. So the cosecant of 11 pi over 6. Cosecant is the reciprocal of sine. Sine is the y coordinate. So ultimately, it's 1 over y, or the reciprocal of the y coordinate. Where is 11 pi over 6, and what does it look like? Now, I'm going to remind you of one thing. When the denominator is 6, it's what's called a 30-degree reference angle. And for a 30-degree reference angle, the x and y coordinate, the x coordinate is root 3 over 2, and the y coordinate is 1/2. You need to dust off your unit circle from a year ago, somewhere in your notes. Now, what I taught you last year is that these radians are in lowest terms, right? And they go from quadrant to quadrant with the next numerator that keeps it in lowest terms. So after 1 over 6, what's the next numerator that wouldn't simplify down? It's 5 over 6. And the next one after 5 is? And the next one after 7 is? 11. What quadrant are we in? So x is positive and y is? So what's the reciprocal of the y coordinate? And the answer is negative 2. Do you want me to put the unit circle lesson and everything else we did a year ago on our website for calculus so you can look at what we did a year ago?
Yes.
All right. 15. 2 left. What time does the bell ring?
19.
Oh, I'm styling. 15.
That's on the good team.
I don't know how I'm styling is like an ooh. It's like you just saw me pop a pimple or something. That's an ooh. I'm gonna say it again. I'm styling. We're ready to go. You tell me the peeps don't say I'm styling? Is that like not
In Canada, they say
my peeps? Number 15. It's asking for a point. Find the points at which a line tangent to that graph is parallel to y equals 5. So, the word tangent means what? The word tangent means what? Derivative, slope, right? Derivative. What's the derivative of this? What's the derivative? When I see the word tangent, I'm taking the derivative. 3 times 1/3, it's x squared. How about the next one? And the next one. Got it? Parallel means the same slope, right? So what's that number? So I'm going to make it equal to what? All right. How do you solve for x here? We're not ready yet. It's a quadratic equation. What do I have to do first? Make it equal to? How do I do that? So now what is it? Now what do I do? You're big enough to do this without a diamond. What are the two numbers? So what are the two answers for x? Positive 3 and negative 1. Now, they ask you for the points, right? So right now we know this. We know the two x coordinates, right? What don't I know? So what do I need to plug in? So I need to plug in 3. So that's 27 divided by 3, which is 9 minus 9, I like that, plus 6. So the answer is 6. So where's one point that would answer the question? 3, 6. Where's the other one? What number do I plug in? Do you know that negative 1 to the exponent 3 is negative 1? Okay? So negative 1 times 1/3 is negative 1/3. This is positive 1, but the subtract sign in front makes it negative, and this is negative 2. Yes?
yes.
This is not as tough as it looks. It's negative 1/3. Combine them together. They're all the same signs. You're adding them. If you really wanted to, you could write it as negative 28 over 3. But I'm happy with negative 3 and 1/3. And you found the 2 points. All right, last question. Number 16, and then this will be uploaded today. All right, use y prime equals 1/2 x squared y to find the following. Find the value of dy by dx at the point 1, negative 2. Now, what does that mean? Plug in 1 and plug in negative 2. So dy by dx, you plug in 1 for x, plug in negative 2 for y. Could you simplify it? So 1 squared is 1 times negative 2 divided by 2. That answer is negative 1, right? Could you find the slope? Next, it says draw a slope field. You didn't think we'd get away with not doing that, right? Draw a slope field. Two by two. See if I can change colors here quick. Where should I start? Where the horizontals are. At what x value is it horizontal? There it is, right there. What x value is it horizontal? When x equals what number? 0. Because 0 times I don't care equals 0. So 0 slope means what? So, can you see where x is 0? What are you going to draw in? Where else? What's the y value that makes it 0? 0. So horizontally, right, across y equals 0, again, is going to be horizontal. Do you see that? So now we just have to fill in the quadrants and see if we see a pattern. So we already did 1 point. Why not start there? That's at 1 and -2. We said the answer was -1. Can we do that? What happens at 1, 1, or 1 and -1? Still negative, but is it flatter or steeper? Flatter. Good. What happens at 2, -1? 2 is 4 divided by 2, which is 2. And -1 makes it a -2. That's steeper, right? How about at 2 and -2? 2 again makes it 2, but times -2 is -4, and that's even steeper. So there's one quadrant. Let's go to the next one. +1 and +1. That's +1/2. Is that steep or flatter? So there's +1/2. How about 1 and 2? 1 and 2. Well, 2 divided by 2, that's 1. Times 1, it's a little bit. It's 1, right? Means it's a little steeper. Here, 2 and 1. That's 2. 2 and 2. That's 4 divided by 2, which is 2, times 2, which is 4. That's steeper. 2 quadrants done. Left quadrant, -1 and +1. When x is negative, does it affect it, or is it exactly the same as the right side? So just do the exact same thing you just did on the right side. How about here? Again, when x is negative, does it change it? Or is this exactly the same as the right side? So whether I put in +1 and -1, or -1 and +1, it's going to give you the same answer when you square it, right? So again, it's exactly what you see. Just mirror it over. All right, now we have a slope field. What point are we going through? 0 and 1. Do you see it? What do I notice about 0, 1? It's a horizontal slope, which means that is either a maximum or a minimum, right, in terms of how we see it. So what direction is it going to the right? Now, what's going to happen as I go to the right? As I go to the left, what's going to happen, you think? So let me double check. So I went -1 squared positive. It's still a positive slope, right, on that side? So what this is creating instead of that, it's actually creating a point of inflection. So it flattens out. Following the flow. And then what's the last thing? Can you actually integrate it? So dy by dx, I'm going to divide by y, multiplied by dx. I'm going to integrate both sides. Make sure you include the candy. When you add 1 to the exponent, it's 3. times the bottom. Oh, man. I'm going to have to finish this, right?
Yeah, finish it. I'm gonna stay.
You staying?
Nah, I'm gonna go.
Kind of looks like this. Then it looks like this. Then it looks like this. Then when you plug in 0 and 1, see 1 equals 1. Awesome. All right. Mr. G. Math, over now.